So just try to get a regular piece of copy paper, white paper. If you have lined paper, that's okay also. And what we're going to go over is something called highly recognizable graphs. So I'm going to fold my paper in half to organize my information. The first graph I want to do is y equals x. And that's just going to look like a diagonal line. You're supposed to start at 0, 0, and then go up 1 over 1, up 1 over 1. The second graph I want to discuss is y equals x squared. Now, if you have an xy axis, it's going to start at 0, 0, and it's going to be a parabola. Now, there's an array of points that goes with y equals x squared, and I'd like you to write this down. It's 1, 3, 5. That means once you find the vertex, you go up 1 over 1, pop a dot. Then from there, you'd go up 3 over 1, pop a dot. Up 5 over 1 and pop a dot. That's the array of points. The third graph we're going to discuss is y equals x cubed. If you have an xy axis, it's going to start low, go through 0, 0, and then end up high. That has an array of points. 1, 7, 19. What that means is you find the turning point, start at the turning point, go up 1 over 1 and pop a dot. Then from that dot, you'd go up 7 over 1, up 19 over 1, but it quickly takes you off the paper. The next graph we want to talk about, y equals x to the fourth. That's going to look like a big W. It's going to look like a big W. I don't want to throw an array of points out for that one. Number six, we start to get away from the polynomial graphs. And, I'm sorry, number 5, Mr. Miller can't count sometimes. Number 5 is going to be y equals the value of x is a v. Absolute value is a v. Little memory mnemonic. Number 6, that's going to be the square root. Y equals the square root of x. That's going to be this little out route. And that starts at 0, 0 also. If I was on the xy axis, the array of points with that is 1, 3, 5, 7. But because it's a radical, it starts at 0, 0. I go up 1 over 1. Then instead of going up 3 over 1, I go up 1 over 3 to land on the next coordinate. It goes out. The football players like to call it the out route. Number 7, y equals. Instead of there being nothing in there, actually there's a 2 for square root. I'm going to put a 3 in there for cube root of x. If I have an xy axis, the cube root is going to look like a super S. The array of points for this is 1, 7, 19. Just like for the cubic. What that means is I start at this turning point, I go up 1 over 1, that lands me on that dot. Then from there, instead of going up 7 over 1, I go up 1 over 7, and it lands me way over there. And then I quickly run off the graph paper with the 19. 8th graph, y equals 1 over x. If I have an xy axis, this graph, this is my knee. It means I'm going to have an asymptote here horizontally, asymptote here vertically. I start at 1, 1. I go right 1, up 1. I pop a dot. That's where I get the 1, 1 from. And it's going to look like this. Then I go left 1, down 1. And that's going to be my graph. Rational expression, it's called. 9th graph, y equals e to the x. So if I have an xy axis, e to the x is going to go through 0, 1. Let's write that down. Then it's going to come through there. It's going to have an asymptote along the x-axis. It's going to hit that 0, 1, and then it's going to exponentially grow. It's going to grow really fast. Running out of room. Number 10, y equals the inverse of e to the x is ln of x. That's going to creep up along the y-axis, go through 1, 0, and then grow slowly. This one grows rapidly. This one grows gradually. That goes through 1, 0. Now I'm going to open up my paper. Going to open it up. And alongside of it, we're going to do the negative version of it. So over here, we're going to do y equals negative x. Y equals negative x squared. Y equals negative x cubed. Y equals negative x to the 4th. Y equals negative absolute value of x. Y equals negative the square root of x. Y equals the cube root of x. Y equals negative, forgot to put the negative in front of cube root. Negative 1 over x. Y equals negative e to the x. And y equals negative ln x. And all these are reflections over the x-axis of the original line. So this one, instead of starting at the bottom and going up high, it's going to flip and start high and go low. It's decreasing. Negative x squared flips that upside down. Negative x cubed, same thing. It's going to flip it and start up high, turning point, go down low. Don't forget the array of points for this one is 1, 3, 5, 1, 7, 19. I would start at 0, 0, go down 1 over 1, down 3 over 1, down 5 over 1. Start at the turning point, 0, 0, go up 1, left 1, up 7, left 1 to get that array of points. If x to the 4th looks like a big W, negative x to the 4th, it's going to look like a big M. Write this down. You want to have these at your disposal. Absolute value is a V, but negative absolute value is an upside down V. Square root is an out route, negative square root. That's an out route for the other team. If you're playing defense, it goes the other way. Cube root, negative cube root. Negative cube root, instead of starting low and going high, is going to start high and then go low. Don't forget the cube root has an array of points, 1, 7, 19. And so does negative square root. That's going to be 1, 3, 5. I'd go down 1 over 1, down 1 over 3, down 1 over 5. This one would use the 1, 7, 19. Negative 1 over x. Instead of starting at 1, 1, it's going to start over here at negative 1, 1. And that's my knee, my knee. E to the x is a growth, but because it's negative e to the x, it gets flipped over the x-axis. So instead of going through 0, 1, it's going to go through 0, negative 1. And then go downhill. Negative ln x is going to go through 1, 0. Is going to go through 1, 0. But instead of growing gradually, it's going to decay gradually. Those are the highly recognizable graphs. There are more, but that's all we're going to do for today. Please have this at your disposal for your notes.